We're going to be talking about relations and functions today. And so the first thing we're going to be looking at is what ways these can actually show up. And so you can have it in order pair format in which you have the input as your X and the output as your Y. And you just list them as order pairs. The mapping is when you have the circles with the arrows that point, and this is your X and this is your Y. The table of values, you have your X's listed first and then your Y's are your outputs, and then the graphing method. And so let's look at this first one. We have a skydiving situation in which the photo represents the various heights, the skydiver at different times. And so the time is the X. That's our X value. And the height is our Y value, or our output value. And so our time was 0 when we're at 10,000 feet. It was at 4 seconds, and we're going to go ahead and put these in order. So we've done this one. And let's go to the 4 second. We're at 9,744 feet at 8 seconds. We're at 8,976 feet at 12 seconds. We're at 7,696 feet. And at 16 seconds, we're at 5,904 feet. And so we've represented it on a table. We could also represent the same information with set builder, with mapping by just drawing arrows from your X value to your Y value. Again, I recommend always putting these in order from least to greatest as you're filling these in. This time they don't have to match exactly going left to right, but they do need to, the arrows will match. But it doesn't have to both match in the order. I recommend always putting these in order from least to greatest. It helps with doing domain and range. Or greatest to least. And we did 16 goes over, and it's 5,904. So it doesn't matter which order you go as long as you go from greatest to least or least to greatest. And again, these are your X values, these are your Y values. The other method is just the order pair, which is pretty much what we just had, but we can also write it in the set notation with the ordered pair, 0, 10,000, 4, 9,744, 8, 8,976, 12, 7696, and 16, 5904. And then close your set brackets. The last way we can represent this information is if we can do this as a graph. And so when we do it as a graph, what you'll see is your X and Y plotted in ordered pairs. And so remember we talked about the X being your time in seconds and your Y being your height in feet. So that's the last method that you could represent it with that we were talking about today. So next we're going to talk about what is domain. Domain is the input values. Most often we think of those as your Y values. And then range is your output values. Most often we call those your Y values. So let's look at this. What is my domain? And so I'm going to go ahead and write my domain. And since this is just a list of points, there's not anything in between, I'm going to use just the set brackets and list them in order from least to greatest. So my smallest x value is 1. My next smallest is 4. My next smallest is 8, then 12, then 16. And on domain, you don't list numbers twice, nor on range. And so let's look at range. Those are your y values, or your output values. And we go from least to greatest again. And so this time, our smallest number is our last number, because this one we're closest to the ground from our previous scenario. 5,904. Then our next highest was 7,696. Then our next highest was 8,976. Then our next was 97.44. Then our highest was at 10,000 when we jumped out of that plane. Next thing we're going to do is determine, is this relation a function? So what makes a function? A function is when the input, is when the input value can't be used more than once. That means we're not repeating the x values. So let's look at our 3 different scenarios. So we're focused in on what's happening on the domain. Is the domain being used more than once? So let's look at these first 2. So 3 is only being used once, so that one checked out. 0 is only being used once, so that one checked out. And 4 is only being used once, so that means it, because there's only one arrow leaving. So this relation is a function. It passes that test. But let's look at this next one. 2 is going both to the 3 and a negative 3 and to the positive 3. So it is not a function because the 2 is being used twice. Now, when it's listed like this, we need to just basically, you want to ignore your range. It doesn't matter. So pretend like it's not there. So the same thing is going to be the true for when we have ordered pairs. We're going to ignore your y values. Are there any x values that get used more than once? So just focusing in on these x values. Well, 4 is used here and here, and they're going to 2 different y's, so therefore this is not a function. So when it's not a function, that just means it's just a relation. All functions are relations, but not all relations are functions. Another way to tell if it is a function or not is to see if it passes the vertical line test. And what that means is we look at a graph. You draw a vertical line, and does it ever touch the graph in more than one location? So like here, we're touching it twice. Whereas here, we're just touching it the one time. But it's asking, does it ever? And so since this does, it is not a function. Let's go ahead and look at this next one on B. As I draw my line across, here I'm just once. Everywhere I'm going so far, I'm just hitting it once. I'm never hitting it multiple. And so that means this passes that vertical line test. That means everywhere on this graph, it's only being touched one time as you're holding that line up. Nope, it's not. It is a function. So let's look at this last one. So B does represent function. And on the last one, C, let's look. There's only one there, so that one's good. Let's go on to the next one. Only one there. Ooh, we have a problem. We have 2 here. So that means this is not a function. And once you see that it fails once, you don't have to keep going. So we're going to use the function below to write the order pairs for this set. And so first off, we just need to figure out what they are. So our input value will go in and replace our x. And so we have -2 times -3 plus 5. So that means that I have a positive 6 plus 5, which is 11 as my output. We'll do this next one, -2 times 0 plus 5. That means I have 0 plus 5, so my output is 5. Last one, -2 times 1/4 plus 5. -2 times 1/4, I think that is -2/1, and reduce, and that gives me a 2 down there. So that gives me a -1/2 plus 5. And I want to think about that 5 in a form that I can work with. And so I want to think of it as something over 2. So that's the same thing as 10 halves, which when I add those together, I get 9 halves. But since I am graphing, I want to think of this as a mixed number, which is 4 and 1/2. And so I'm going to go ahead and write out my ordered pairs. -3, 11, 0, 5, and my last one was 1/4, 4 1/2. So set builder is one of the ways we can use to write notation. Set builder, you identify your variable and then you state the rule. And it's like x such that whatever the rule is. So we could have something like x such that it is an even number. X such that it belongs to the reals. Or it could be something like x such that x is greater than or equal to 7. So it can be a general rule, or it can be very specific, narrowing it down to where it's located. Interval notation. We have several different things we'll be using for interval notation. Use parentheses when you would have used on writing it, you would have used greater than or less than. This means we can't be exactly at that point. Okay, let's go on to the next one. The next one, we have our closed brackets. This is used when you would have used the greater than or less than, or greater than or equal to, or less than or equal to. And that's when you can be at that point. And then two other things we'll have. If you ever have a positive infinity, it has to be connected to a closed or open parenthesis. And that means it goes forever in the positive direction. And then the last one, if you have a negative infinity, so it should be a comma in front of that, it goes forever in the negative direction. And what's really neat is you can actually have one of these as your starting bracket and then end up here. Or you can have a parenthesis and have a bracket. You don't have to have both sets match. So you just kind of look at each one. Can I be at that location or not at that location? So the last thing we're going to do, and then I'll let you work on some of your assignments, is we are going to write the domain and range using both notations, the set builder and the interval. So let's look at the domain. Domain are our x values. So looking here, that means this graph keeps going up and going up. So that means we're eventually going to cover all x values. So that means on set builder notation, we have x such that it is a member of the reals. On interval notation, that same thing is written as negative infinity to positive infinity. And we talked about on that if you ever have the infinities, they have to have the parentheses. Now let's look at our range. So we look and see, where is my lowest point or my highest point? Is there one? So my lowest point is at -3, and then I go up from there. So that means that all my y's are greater than, and since I can actually be there, it's greater than or equal to -3. So my set builder notation is y such that y is greater than or equal to -3. My interval notation, we start off at your lowest value and go to your highest. And so my lowest value is at -3, and I can be there. My highest value, I keep going forever in that positive direction. So I don't have a highest value. I have positive infinity.